Okay, so we're going to do integration, kind of our last bit here with inverse trig and some other things thrown in there as well. So let's remember, what is the derivative of arc sine? Do you remember that? So the derivative of arc sine of u is u prime over the square root of 1 minus u squared. And what's the derivative of arc tangent was u prime over 1 plus u squared. Now you might be saying, why did you not do arc cosine? Because remember, arc cosine just has a negative right here. So when you integrate, you only ever integrate back to arc sine or arc tangent. So that means that if I integrate, if I have u prime over 1 minus u squared, then that's going to integrate to arc sine of u plus c. And likewise for tangent. So it's yet another thing that a quotient could possibly be. It could be an arc sine or an arc tangent problem. I don't think of these the first thing off the bat. It's just like when I've eliminated everything else. When I know it's not a natural log, I've eliminated that choice. I know it's not a power rule, and it has this form. Then, of course, that's when I think of the arc trig. So here's what I want you to look at. In example 1, there's actually 3 problems in example 1. Here, here, and here. Now what I want you to look at, and they look so similar, and that's why integration is so difficult. You actually know right now how to integrate 2 of those things. And I want you to try to figure out which 2 you know how to integrate. So stop the video and see if you can figure out 2 of them and then come back. Well, the first one you know how to integrate is actually this very first example. Because if you look at the entire denominator is 1 plus x squared. So its derivative would be 2x dx. Do you notice how you have that in the numerator? You have the x part right. So like I said, I usually, when I have a quotient, the first thing I try is it going to be a natural log? I look at the denominator. I do have the numerator, the derivative in the numerator, except for this 2, which of course I can fix by just multiplying by 1. So what I'm really integrating is u prime over u. This is u prime, so I have u prime over u. Remember, that's integrating like this. So I say, oh, this answer is 1/2 natural log. I can put the absolute values, but since my denominator is already all positive, a lot of times they type it without the absolute values. If you wrote them, it would not be incorrect, but it can be typed that way. In the same way, you also know how to do this bottom one, because if you rewrite that denominator, now it's not going to be a log problem because the derivative of the denominator, ooh, it's ugly in itself. It has square roots and a lot more than just x. So I know it's not a natural log, but it's really a power rule problem. And once again, you have to have the inner derivative, the derivative of this, sitting next to your dx. So in the same way, our u is 1 plus x squared, our du is 2x dx. So all I have the x dx, I need a 2 and a 1/2, and that gives me the green light. This poofy clouds away, and I have the green light to do the power rule. So how do you integrate something to the power? I increase the power by 1 and multiply by divide by that power, or multiply by the reciprocal since it's a fraction. I can't forget that I also have this 1/2 that gets brought down. What's inside here doesn't change. And so what do I get? Those go away, and I get the square root of 1 plus x squared plus c. So know that on your homework, there's going to be some old ones, because that's part of the difficulty, is figuring out, okay, is it an arc trig or is it one of the ones that we've done in the past? So it's good for me to put all sorts on your worksheets to kind of make you practice that. But then, so let's say we get to this one. my mind, when I first would start this, after you see these, I hope that you'll think, oh, it's not a log because I would have to have an x in the top, which I don't. I can't, if you don't have variables right, you can't fix that. So you go, okay, it's not a natural log. It's not a power rule because again, if no, I'd have to have an x. So you're kind of out of things to do. That's when you think, oh wait, does this look like an arc trig? And so if it's an arc trig, y'all, it has to have one of these two forms, this or this. Now, obviously, which one does it look more like? This one, because there's not a square root. So when I think it's an arc trig, as silly as this step may sound, I think about actually isolating and making it look like showing me what the u is. Because notice here, my u is not x squared, it's x. Because see how that's u squared? So wouldn't du or u prime be 1 dx, which is what I have in the numerator. So do you see that I have u prime over 1 plus u squared? That's what's really sitting there. And so how does this integrate? It integrates to arc tangent of u, which that's why I like to kind of write it this way, plus c. And there you go. You look at example 2. Is it a log problem? No, because the derivative of this entire denominator is really complicated, and I certainly don't have the variables right in the numerator. Is it a power problem? Well, if I thought that and I wrote this way and started doing a power problem, you have to think, I have to have the derivative of the inner next to dx. Well, the derivative of the inner would have an x in it. Do you have that? No, so it can't be a power rule problem. So it's okay if you try something, but you've got to be able to figure out that it's not that. So then you think it's not log, it's not power. Oh, ooh, it kind of looks like that arc sine one. So let's get it in the form of the arc sine, which means I'm going to write it as 1 minus parentheses something squared. What is that something? Of course, 4x. So my u is 4x. Well, what's the derivative of that? Well, that's 4 dx. So I would have to have, what am I missing? What I need in the top, see how I'm only missing a number? Just like we've done for all the other problems, I can put a number in the top. I can fix that as long as I multiply by 1. So I'd have a 1/4. And then, do you recognize all of this as u prime over the square root of 1 minus u squared? How does that integrate? Arc sine of u, and my u was 4x plus c. Can't forget the 1/4 on the outside. And there you go. Let's look at a few more. Oh, what's different with this guy? Okay, so this one has an evaluation, but that's just one extra step. Does that 8 bother me? No, because I can just pull that out. Remember, if you have a constant, I'm able just to pull constants outside of the integral. And if I write it like that, well, you should recognize this guy as something that we actually already integrated on the front side. And so again, 1 plus, think of it as that. So my u is x. The derivative of x is on top is 1. So this integrates to 8 arc tangent of x. And I just have to evaluate from -1 to 1. So of course that's 8 arc tangent of 1 minus arctangent of -1. So this kind of involves you remembering on both with arc sine and arctangent. The good news is you're always looking at those two quadrants, remembering that quadrant 4 you name negatively. So if I want to do the arctangent of 1, that's going to be in quadrant 1. What arc has a tangent value of 1? Those are the pi over 4s, so that's pi over 4 minus. Now the arctangent of -1, that's in quadrant 4, so I don't put 7 pi over 4, I put negative pi over 4. When you're evaluating, all your answers have to, when you're doing the arc trig part, now your final answer may be different, but when you're going from this step, all for arcsine and arctangent, all of your answers have to be between negative pi over 2 and pi over 2. So to finish that up, 1 pi over 4 plus, that's really a plus there, so that would be 2 pi over 4 or pi over 2 times 8, so I get a final answer of 4 pi. All right, let's look at example 4. Now you look at example 4, and again you go, is it a log problem? Nope, it's not a log problem because why? Because you'd have to have an x up top, which you don't have. It's not a power rule because, again, you'd have to have x's. So you can't divide anything. I mean, I'm kind of stuck. Believe it or not, this is an arc trig function. And you're like, no, it's not. It doesn't look like either one of those. Well, unfortunately, it doesn't look like it, but I can use some math, some completing the square to make it look like it. So when I say completing the square, do you remember what I'm speaking of? I'm basically going to rewrite this denominator in a clever way. So here's what I want to do. Notice what I'm doing. I'm going to put in some blanks, and I'm going to do those in a different color so you can see. Y'all, I can't change the problem. I can't change what the denominator is. So notice that right here, if you look at that denominator, I have the exact same thing, I just have blanks in there. Now remember, we said over here, you can, on the front side, you can, to not change your problem, you either can multiply by 1. What can you add that wouldn't change it? 0. So I have to remember that I can only add 0. So I'm going to remember that when I fill out these blanks. I am going to pick a number in this blank to make this a perfect square trinomial. Now, what number is that specifically? You take half of this guy, which is 2, so half of this number, and then you square it, and that's what goes there. So half of 4 is 2. 2 squared is 4. Now look, if I reduce this denominator right now, if I clean it up, do you see that I have plus 9? That's not what the denominator is. So when I put plus 4 there, I have to take out 4 there. So that, look at that denominator. If I reduce that denominator, do I get back down to what my problem is? Yes. Now, why did you do that? The whole point is so that if I said factor this, if I just ask an algebra 1 student, factor this for me, they'd do their little things, and they'd say, well, it'd be x and minus and 2 and 2. Or in other words, x minus 2 squared. That's the whole point of you picking that number, is that this becomes, you're picking a number so that when you factor, you get a perfect square trinomial. So that's x minus 2. This sign is always what comes down, and the number is the square root of that number. And then let's just clean up this. What is 5 minus 4? Then you have 1. Well, oh my. Now I have them written in a different order, but y'all, look what you have. You have u prime. What's your u? U is x minus 2. What's the derivative of x minus 2? Well, 1. So do you see right here, I have u prime over 1 plus u squared. So how does that integrate? Arc tangent of u plus c. And that's my final answer. So look for that completing the square. Again, when you know it's not a log and you have a square down there, a polynomial like that that has a squared, then you're going to look to complete the square. All right, let's look at examples 5 and 6. The good news with this one's a surefire thing as well. it kind of leads you to the next step. If the degree of the numerator is greater than or equal to the degree of the denominator, then use long division to rewrite the quotient. Well, we've done division. Like, I'm not going to do this problem, but if I gave you 9x squared plus 4 over x cubed or something like that, okay? Or I'll make this x to the 5th or whatever. If you have a monomial, you know, if I had that, you'd go, oh, well, I'll just reduce that. That's 9x squared plus 4x to the negative 3, and I could just go and straight integrate. So if you have a monomial, then yes, just straight divide and you'll get it. The trouble is looking at these denominators, well, I am going to divide, it's just that it takes a little more effort, okay? When the degree of the numerator is greater than or equal to the degree of the denominator, then use long division. Now let's think of long division for a minute. If I go 3 into 17, you say, well, that's 5, and then that would be 15, and then what is this 2? It's the remainder, right? So if I ask you to write the answer, like without the word remainder, 17 divided by 3 is 5 plus remainder over divisor, right? Wouldn't it be 5 2/3? 5 plus 2/3? Okay, we're going to do this exact same thing with polynomials. I'm going to put x plus 3 into 3x plus 4. What do I need to multiply x by to get 3x? Well, I need a 3. I then multiply like I did here. So that would be 3x plus 9. Then what did I do? I subtracted. So when I subtract, of course, don't forget both things. So 3 minus 3x, of course, those go away. This is 4 minus 9, and that's negative 5. Now, what is this negative 5? That's the remainder, correct? But let's write that the same way I did up here. The long division doesn't do the integrating, it rewrites your quotient. So this would be 3 plus a negative 5. Now granted, you could write minus. 3 plus a negative 5 over x plus 3. This is what I need to integrate. That's what I'm integrating. And remember, I'm going to do those separately. So think about integrating 3 dx plus the integral of a negative 5 over x plus 3 dx. You're going to look at them totally separately, and you should be able to integrate both of those. Well, this guy's easy. That's 3x. This guy, let me just move the negative 5 on the outside to get him out of my way, and then I'd put a 1 out there. How does that integrate? We'll look at the denominator. The denominator is x plus 3. What's the derivative of x plus 3? 1. So what is that? What is that integration? U prime over u, how does it integrate? The negative 5 comes along, natural log absolute value of x plus 3 plus c, and there you have it. All right, let's see if you can try number 6. A little bigger, but let's see. Let's do, how do I know to do the long division? The degree of the numerator is bigger than, greater than or equal to the degree of the denominator. I don't have a monomial in the bottom, unfortunately, so I have to do it like this. Pen's getting a little shoddy there. Okay, here we go. So what do I need to multiply x squared by to get x to the 4th? I need to do x squared. When I multiply, I just be careful to line my things up. I would have x to the 4th plus x squared, correct? Now remember, I'm subtracting, so these guys cancel. I do have this negative 2x cubed, and then those cancel. And then I can bring down the negative 2x. So what would I need to multiply x squared by to get negative 2x cubed? Well, I would need a negative 2x, correct? Now let me multiply. So I'd get negative 2x cubed minus 2x. When I do the subtraction, both of those cancel, but don't forget that this guy still comes down, so I have a 2. Now obviously x squared can't go into a 2. Remember, when you're writing this, you should only have positive values for your exponents. So this is actually my remainder. So what am I integrating? This whole thing, remember the long division doesn't integrate, it rewrites the quotient. That whole thing is equal to x squared minus 2x plus 2 over x squared plus 1 dx. All right, let's do it. So this integrates to 1/3 x cubed. This integrates, increase the power by 1. And how does this integrate? That's today's lesson. Take the 2 out, then you have an u prime. So again, think of it like this, 2 over 1 plus x squared dx. Take the 2 on the outside, so just move him out here. This is u prime over 1 plus u squared. So I get 2 arctangent of x plus c, and voila, you are finished. So it has lots of different things. The arc trig, you look for completing the square when you don't see it. When the numerator, degree of the numerator is bigger than the degree of the denominator, then you look to do long division. A lot of times with that division, you get down to either a log or another arc inverse trig. So that's why I kind of waited to do those now. And there you go. So your homework, they're all going to be mixed up. So practice, practice, and peace out.